Guys, today I am here to discuss about the Thevenin's theorem. So at first we have to know what is the Thevenin's theorem and why we need it. The theorem is any active linear bilateral network consisting of independent or dependent current and voltage sources can be replaced by an equivalent circuit consisting of an independent voltage source VTH connecting with RTH in series, where VTH is the open circuit voltage and RTH is the equivalent resistance of the network as seen from the load resistance RL, with all internal sources replaced by their internal resistances. And we needed to calculate the open circuit voltage, but in exam we have to calculate the Thevenin's current also. So go to the problems. Here is our first problem and it is the circuit diagram. Here we have to calculate the current flows to the 12 ohm resistance. Here so the 12 ohm resistance is the load resistance. So the equivalent circuit will be this. Here we have to remove first the 12 ohm resistance and it is the load resistance. As 12 ohm resistance is parallel to the 6 ohm resistance, so the current flowing through the 6 ohm resistance will be equal to the current flowing to the 12 ohm resistance. And as said in the theorem, we have to see from the load resistance side, so the arrow is here. So at first we have to calculate the line current. The line current will be the 36, the voltage source into, sorry, this will be by the equivalent resistance. So here the equivalent resistance will be 3 plus 6, that will be 9. So the current will be 4 amperes. Next we have to calculate the Thevenin's voltage. So to calculate the Thevenin's voltage, we apply the Ohm's law, that is V is equal to IR, that is line current into R. So that will be 4 ampere, that is the line current, and the R will be 6, as we have to calculate the open circuit voltage, that is the 6 ohm resistance. So it will be 24 volt. Next we have to calculate the equivalent resistance or Thevenin's resistance. So the circuit diagram will be for the equivalent resistance calculation will be that. So and the equivalent resistance 3 ohm and 6 ohm are in parallel, so and with this the 4 ohm resistance is in series, so plus, so this will be that is 6 ohm. So next we have to calculate the Thevenin's current, and in exam we have to calculate this, and the formula is Thevenin's voltage divided by line current plus Thevenin, the line resistance plus Thevenin's resistance or equivalent resistance. Here we have calculated the Thevenin's resistance before, that is 24 volt, and the line resistance is or load resistance is 12, and the equivalent resistance is 6 ohm. So after calculation we get 24 by 18, and that will be 1.33 ampere. And after calculating the Thevenin's current, we also draw the equivalent circuit. If we do not draw the equivalent circuit, we do not get the full marks, and the equivalent circuit will be here our voltage source VTH in series RTH or equivalent resistance, and here the final load resistance, and we have to put the value here, that is the VTH, and it equals to 24 volt, and it's the Thevenin's resistance, and it's equals to 6 ohm, and here our load current, load resistance, and it is 12 ohm. So our Thevenin's voltage is 24 volt, and Thevenin's current is 1.33 ampere. So I repeat it once again. Here is the circuit diagram, and we have to calculate the current flows to the 12 ohm resistance. So here the load resistance is 12 ohm, so we have to remove the 12 ohm resistance at first, as 12 ohm resistance and 6 ohm resistances are in parallel, so the current flowing through the 6 ohm resistance will be equal to the current flowing through the 12 ohm resistance. So we have to calculate the current flowing through the 6 ohm resistance. As in the theorem, we have to see from the load resistance side, so the arrow is from here. So at first we have to calculate the line current. Here the voltage source is 36 volt, and we have to calculate the resistance, that is 6 ohm plus 3 ohm, that is 9, and we have line current, that is 4 ampere. Next we have to calculate the Thevenin's voltage, and we have applied the Ohm's law, that is V is equal to IR. Here I is equal to the line current and R equal to the 6 ohm, as we have to calculate the current flowing the 6 ohm resistance. So and the Thevenin's voltage in 24 volt, and next we have to calculate the equivalent resistance of Thevenin's resistance. So we have to remove all those voltage source and current source, and the equivalent circuit for the calculation of equivalent resistance is this, and here the calculation of equivalent resistance. And next we have to calculate, and the final calculation is for the Thevenin's current, and the formula is Thevenin's voltage divided by line resistance or load resistance plus Thevenin's resistance. And the calculation, after calculation I get that is 1.33 ampere, and after that finally we have to draw the equivalent circuit. If we do not draw this, we do not get the full mark. So it is important to draw the equivalent circuit after calculation, and equivalent circuit will be this. Here the Thevenin's voltage 24 volt, and in series Thevenin's resistance or equivalent resistance, that is 6 ohm, and here the final load resistance RL 12 ohm. So thank you for watching. Please subscribe our channel and like it, and put on the notification bell. Thank you.